Within Hoist's 550,000 square foot manufacturing facility, Hoist houses a dedicated plasma department in which several nesting engineers configure the most efficient ways to schedule and cut steel. When it comes to steel use in the manufacturing of high-capacity products, there is no one-size-fits-all solution to the development of products that demand both versatility and resistance to extreme stress in some of the harshest applications spanning a variety of industries. Hoist's engineering team reviews the various requirements of any given design when selecting materials and uses those criteria to select the most appropriate steel. The FR Series mast and boom are no exception, with the design following this same protocol. Proper design of steel fabrications considers many factors including required strength, weight limitations, type of loads or loading, deformation limits, formability, and weldability of materials, to name a few. Often a combination of materials will provide the optimal solution to address the various requirements of any given design. While T1, also known as ASTM A514, is efficient in maximizing strength and load-bearing points, a weakness is its limited ductility, a variable which cannot be overlooked in the heavy lifting industry. To put this principle to practice, we can see from this example the paperclip, or A572, is able to bend or deflect, while the pencil, like A514 or T1, becomes brittle and fractures. Care must also be taken when welding, as T1 requires much more stringent procedures and guidelines, with pre- and post-heat treatments requiring strict adherence in order to alleviate cracking due to hydrogen embrittlement. While T1 is utilized on all major load-bearing members, A36 and A572 steels are also utilized in a cohesive design to produce a fabrication that not only meets strength requirements, but also reduces the potential for cracking or brittle fracture. For this reason, the Hoist FR Series masts, carriages, and booms are designed using multiple grades of steel to best address the requirements of any given part, while providing the best means of manufacturing to mitigate potential concerns related to specific characteristics of the various grades. In the following videos, we will review A514 and A36 steel of the same exact dimensions under mirroring bends to highlight their deflection tolerances. First, we will review A36, a steel featuring excellent formability and weldability. A36 is utilized on many of the non-load-bearing cosmetic pieces of the build, for example hose brackets and cylinder covers. We can see from this test A36 and materials like A572 are more ductile and will deform without cracking or fracturing. In this video, we will review A514 or T1 and its inability to deflect under the same circumstances as the A36. From this test, we are able to see the discrepancy in the material's ability to handle deflection. To simply state a fabrication is made entirely of one material because it is stronger than another discounts all other variables, which may in fact result in a design more prone to cracking or other undesirable characteristics. All Hoist designs are subject to FEA, finite element analysis, during the development process to aid in determining appropriate materials to not only meet the functional needs of any given requirement, but also to provide an adequate safety factor. All of the major load-bearing elements on the FR Series mast design utilize T1 steel, including but not limited to both inner and outer mast webs and mast channels. Similarly, the vertical nested box sections of the boom are also fabricated from T1 steel. As these elements are loaded in compression and space is limited, T1 is well suited for these components. High tensile alloy steel such as T1 is not better suited for all situations, however. One such situation is designs dictated by deflection rather than yield strength, such as is the case with the horizontal element of the FR boom.